The word dinosaur comes from Greek and means terrible lizard. One such dinosaur, Amphicoelias, was the largest land animal ever to exist, measuring 60 meters long and weighing around 135 tons. However, the only remaining record of this dinosaur is in the sketches of the person who described it, as the bones have been lost and the studies were conducted in 1870. This makes the accuracy of the information about this giant still questionable, which is why the current best candidate for the title of largest dinosaur is Argentinosaurus hunkilensis, which may have reached 40 meters in length and weighed 60 tons. But there's a limit to the size of these animals, as well as the size of animals in general. This limit is determined by physics, more specifically by the pressure these animals exert on their lower limbs, their legs, or in some cases, their upper limbs too. This pressure can be calculated using a simple formula by dividing the force generated by the animal's weight by the area of the limbs. From this formula, we can deduce that if we want to increase the size of an animal while keeping the pressure constant to avoid breaking the legs, the size of these limbs must also increase. For small animals, this isn't an issue, but for large animals, the size of their feet and legs would eventually become too large to allow movement, and their bones wouldn't be able to support the weight while running. This is why there are no giant land animals on Earth. What you're seeing now is a graphical representation of the size-weight relationship among some animals. As you can see, they more or less align along the same line. This is because animals have a relationship between their femur and humerus that determines the weight an animal can support relative to its size. Whales living in water can support the approximate theoretical limit, the point at which an organism with these characteristics becomes unviable. Dinosaurs were already pushing this limit, which is why the blue whale is currently the largest living being that has ever existed on this planet. The famous Tyrannosaurus rex, for example, is far smaller than the largest dinosaurs. It has been calculated that for a T-Rex to run at 72 kilometers per hour, the muscles in its legs would have to account for 86% of its total muscle mass. This is biologically unfeasible. In fact, many footprints of these fierce dinosaurs have been found, but none indicate running, making it impossible to calculate their speed. This also suggests that they might not have been capable of running at all, which lends support to the hypothesis that they could only reach speeds of up to 20 kilometers per hour, meaning you could have. But we're here to talk about dinosaurs, and surely you've thought about cloning. How many times has cloning appeared in movies related to dinosaurs? This is Dolly the sheep, the first mammal cloned from an adult cell. To create her, the nucleus of a differentiated cell, meaning a specialized cell like those in your skin, which are not embryonic, was inserted into an enucleated egg. The resulting embryo was developed in a surrogate mother, and after a while, the famous sheep was born, living for 6 years. Cloning has evolved greatly over the years, and after Dolly, many other animals were cloned for various purposes, from simple research to the revival of extinct species, and even a company that specialized in cloning a domestic animal. This company was the first to clone a domestic animal, a cat named Copycat, which lived in perfect health with its owner and had 4 kittens. So, why aren't we cloning dinosaurs if cloning is already possible? Well, there's a small difference between Dolly the sheep and dinosaurs. The DNA used to create Dolly came from a sheep that was alive at the time of extraction. Dinosaur DNA, on the other hand, is much harder to obtain, mainly because they've been extinct for millions of years, so their remains usually don't contain DNA. The remains we find of these amazing animals almost never contain any DNA. But here's amber fossilized tree resin that can contain insects. Amber that is millions of years old has been found, with some specimens containing mosquitoes that might have bitten dinosaurs, potentially carrying dinosaur blood. The problem, once again, is DNA. It degrades very easily when exposed to the elements, making it almost impossible to find usable dinosaur DNA for cloning. Although we may never be able to clone dinosaurs, we can always watch movies or look through a telescope. A light year is the distance that light travels in 1 year, a vast distance. But the fact that light takes time to travel from one place to another has some very interesting implications for the topic of dinosaurs. In our daily lives, we don't perceive light as having a limited speed, but when we look at space, where distances are immense, this property becomes quite evident. In fact, when you look at the stars at night, the light you're seeing was actually created a long time ago. The light from those stars has been traveling from them to you for years, so some of those stars might not even exist anymore. A fascinating example is Betelgeuse, a red supergiant star in the constellation Orion, and the ninth brightest star in the sky, with the characteristic orange glow. Astronomers predict that Betelgeuse will eventually explode in a supernova. There's some debate about when this event will occur. Betelgeuse is about 10 million years old, but due to its large mass, it has evolved quickly. Some experts believe the star is in the final stage of its life cycle and will explode within the next 100,000 years. However, it might have already exploded, but since Betelgeuse is approximately 643 light-years away, if it explodes today, we won't know about it for another 643 years. The event will be spectacular. When Betelgeuse explodes, it will shine at least 10,000 times brighter than a typical supernova, given its proximity to Earth, with more brightness than a full moon, lasting several months. It will be an extremely bright point in the sky, visible even during the day. After this period, it will gradually fade until it's no longer visible to the naked eye. Orion's right shoulder will disappear until, after a few centuries, a splendid nebula develops in its place, something that might have already happened, but due to the speed limit of light, we don't know yet. You might be wondering what Betelgeuse has to do with dinosaurs. It may seem strange, but they have a close relationship with the idea of seeing dinosaurs. The light from Betelgeuse and other stars, as I mentioned, takes time to reach us, so it's correct to say that we're looking into the past when we observe other stars. Here's where it gets interesting. Just as we can see the past, someone far from Earth could see our past. This is fascinating because imagine we one day discover a way to travel faster than light, perhaps through wormholes or warp drive or some other method. Imagine we could travel faster than light and intercept the light that left Earth around 65 million years ago when the dinosaurs were about to go extinct. At that point, if we could reach that place, we could point our telescopes at Earth and see what happened at that time, actually seeing dinosaurs. The idea of seeing living dinosaurs is undoubtedly fascinating. Though theoretically possible, the reality is a bit more complicated. Earth is very small, and 65 million light years is an incredibly long distance. To put it into perspective, all the stars visible in the night sky are within about 1,000 light years of us. The Milky Way is about 100,000 light years across, and Andromeda, the nearest galaxy, is about 2.5 million light years away. Look at this picture. The bright band on the right is the Milky Way, and that small bright disk is our immense neighboring galaxy. As you can see, it has to be very far away for us to see it so small, and that's just 2.5 million light years away, while dinosaurs are 65 million light years away. This means that if extraterrestrials or hypothetical wormhole travelers wanted to see living dinosaurs, they'd have to travel very far and build a very large telescope. In fact, from Earth, we can barely see planets near our solar system. So how big would this hypothetical telescope need to be? Astronomy gets more complicated the farther out you look, requiring increasingly large telescopes to achieve the same resolution. So let's use the optical resolution equation to find the approximate size of the lens that would allow us to see dinosaurs with good resolution. We'll choose an appropriate wavelength, in this case from the visible spectrum, which corresponds to about 500 nanometers. We'll use the distance of 65 million light years and the radius of the object to be observed in this case, Earth, resulting in a lens diameter of about 58,000 million meters, roughly a third of the distance from Earth to the Sun. That's a very large size. The lens would barely fit between the Sun and Mercury. But we said we're here to see dinosaurs. so the object to observe is much smaller than Earth. This changes the calculations a bit. Let's use the same equation again, but substitute the size of a dinosaur instead of Earth's radius. For example, 9 meters, approximately the length of a triceratops. The result is that the lens diameter required to see dinosaurs would be 4.4 light years in diameter. So far, so good, right? But here's where a little problem arises. If a mirror of this size were created, space-time would start to curve significantly, possibly even collapsing into a black hole. For something with the density of glass, about 2.5 grams per cubic centimeter, it would reach the point of collapse quite quickly. In fact, just a crystal sphere with a radius of 14 light minutes would have enough concentrated mass to collapse into a black hole. Phew, this method of observing living dinosaurs is getting more and more complicated. Unless aliens record them and show them to us in the future, or we find some material light enough not to collapse into a black hole, or we figure out a way to counteract the effects of space-time warping, it's very unlikely we'll be able to see dinosaurs using this method. However, what we can observe are ancient human civilizations since their light is still in our stellar neighborhood. But we're not here to see ancient civilizations, we're here to see dinosaurs. And don't think you'll leave without seeing any dinosaurs. In fact, to see dinosaurs, all you have to do is look out the window and find a bird. Yes, birds are not just descendants of dinosaurs, they are dinosaurs. Dinosaurs are a clade, which is a branch of a phylogenetic tree that includes both living and extinct species that share a common ancestor. The diagram you're looking at now represents a simplified version of the Dinosauria clade. As you can see, birds are at the end of one of the branches. Seeing it this way, you might not believe what I'm telling you, and that's understandable because modern birds have evolved a lot since the rest of the dinosaurs went extinct, so they've changed significantly. Even so, they still belong to the same clade. Let's look at the famous velociraptor, a theropod, one of the fossil species commonly accepted as being closely related to birds. As you can see, it's not that different from a chicken. It's smaller, yes, because that's probably what allowed them to survive. Only the smaller dinosaurs with lower energy needs survived the meteorite cataclysm. And there's also the famous Archaeopteryx, an extinct genus of primitive birds with characteristics intermediate between theropod dinosaurs and modern birds, considered the missing link between dinosaurs and other dinosaurs. When people are told this, many feel a bit disappointed, and that's understandable. I include myself in that. It's fascinating to have living dinosaurs among us today, but what people really want to see are those fierce, gigantic animals that existed millions of years ago, something we've been trying to do throughout this discussion and still haven't achieved. But it's precisely because birds are dinosaurs that we might one day succeed. Epigenetics is the science that studies all non-genetic factors that influence the development of life. The DNA of all animals contains genes that don't always manifest. When we evolve, our genes aren't always suppressed. They're often just turned off but can be turned back on. For example, we humans have some genes turned off that, if activated, would make us grow thick, dense hair all over our bodies. However, there are people who have these genes activated and have hair all over their bodies. The interesting thing is that the same thing happens with birds. For example, it's possible to make a chicken develop a strong jaw with powerful teeth, and this can be done with many other characteristics, possibly using reptiles to restore traits that we could reactivate through epigenetics. By using a computer to program it, we could create something very similar to a dinosaur. For example, we could use crocodiles to lay eggs that would contain dinosaurs. This is something that isn't currently possible, but all indications are that it could be in the near future. However, an important ethical debate arises here. Is it fair to bring animals back to existence after they've been extinct for so long just to confine them in zoos?